Hey everyone, it's Matt here with Nightrun Studio, and welcome back to our Enemy AI mini-series, where we're starting with movement type states and then moving on to combat. In our last video, we got a foundation laid, but because we were laying a foundation, it means that it took a very long video to get just one simple state. Because we are doing the hard work of laying this foundation, we're going to find that each new state we create gets just a little bit easier. And so in this video, in roughly the same amount of time, we're going to create 2 states and also add animations. That's where we're headed in this video. Let's get started. So the very first thing we're going to do is actually get this guy animated, and we're going to do animation for all of our major states all at once here. So let's find our kobold character. Now in the last video, we already set up our sprite editor with 16 pixels per unit, point no filter mode, and 32-bit format, so we don't have to do that again. That said, we will have to do a bit of slicing. I'll show you what I mean here if we go into the sprite editor itself. You'll notice that each of these is already pre-sliced, but they're sliced at different sizes, and this will come back to bite us in a second, but follow along with me anyways. Let's go ahead and click our kobold and create our first animation. I'll put this in our animations folder, and I'm just going to call this one kobold attack. We can go ahead and shift click all of our sprites here and drag them up. Don't forget to repeat the last one just so that that final frame lasts as long as the others. We can then drag this one out, and when I hit play, you'll notice that it's a little jittery and kind of jumping around, with him sometimes floating on air and sometimes not. That's the reason we need to slice this. So let's click on attack and go back to our sprite editor now. Now this sprite was made on a grid that is 148 by 96 pixels. So we'll do that, we'll slice it, hit apply, and now when I click on each of these, you'll notice that the pivot point is very close to his eye in each of these, and that's sort of what we want, a roughly similar pivot point so that he's not bouncing around, but staying more or less in the same place with just a little movement because he's, well, moving. All right, that's looking much better, other than the fact that he's in the floor, but we'll fix that in a moment. Let's go ahead and create our other animations, so we'll create a new one. We're gonna call this one Kobold Idle. Now we can open up the sprite editor for this one. Once again, we'll make it 148 by 96 and apply those changes, and then we can close this up. Once again, we'll shift click all of those sprites, drag them up here, make sure that we copy paste the last one again, and we can drag this one out over a little longer time since we want him to idle slowly. That's looking not too bad. Let's go ahead and create our next, which is going to be the Kobold Walk. Now I'm not going to worry about the slicing just yet. We'll just shift click those, drag them up, copy that last one, and then drag this out, and we want this one to be moving fairly slowly again, so we can drag it out over a slightly longer time. That's looking not too bad. Now we can create our final animation for today, and for this one we're going to do Kobold Run, and we're actually just going to use the exact same sprite, so we can literally just copy them right out of here. And then we'll just drag those in a little bit so that they happen quicker, since this is a running animation. With that done, we can finally slice this last set of sprites, so let's click on Run and go to our sprite editor. Once again, we'll set these up at 148 by 96. Now when we click on the kobold though, we have a problem, because you can see here in scene view that our collider is no longer really anywhere near our actual kobold. So we want to resize that so that it's actually showing up where he is. And then we're also going to need to reposition our ground check and wall check. Now we'll just drag our player back up on top of the ground and then hit play to make sure things are still working. Now because we made the attack animation first, that one will play by default, and here's what I really want to draw attention to. When we get to the wall and he tries to flip, he gets trapped inside of the wall. Now the reason for this is because of the way his pivot point is set up. Currently, he literally teleports to the other side of the pivot. That's going to be problematic. Now if we take a look in attack, this one's not so much of a problem. His pivot is relatively close to his center, and to be honest, he's never going to flip while attacking, so we can leave that one. That said, if we head into idle, the pivot is out in front here, and so his entire body is jumping to the other side. Idle will sometimes need to turn around, so we need to fix this. Now we could manually drag that pivot into the correct place for every sprite, but that's a real pain. So instead, we're just going to slice these a little differently. Instead of using 148, let's make this size smaller so that his center is in the right location. I'm going to try 132, and that looks not too bad, but let's actually make it a tiny bit smaller yet. At 130, that pivot is pretty close to his center, and I'm liking that better. Now that works great for our first frame, but now all of the others are misaligned, so we're going to have to add some padding in between them. Now we took away 18 pixels in the size of this, so we're just going to add a padding of 18 between each one, and now they'll be in the right location and roughly the right size for everybody. Now we're having the exact same problem in run, and so I'm going to slice it up the same way using 130 for width and a padding of 18. We'll apply those changes and close the editor. Now I just want to check one more time since our pivot is changed to make sure our collider's in the right location and actually covering his body. Now we're almost ready to test and just make sure we haven't broken anything, but first let's go into our animator where we're going to set idle as the default state. I'm also going to come back into our scene view and make sure that our wall check and ground check are in the right position, as since we changed the slicing, they're going to be a little misaligned. Now when we get in the game, things are looking pretty good and he's no longer getting stuck in the wall. Now we're ready to actually set up our animator. So if we go in here, I'm going to set this up so that we can use it for any enemy. So we don't want kobold on the name of the states. We're just going to rename them to be the actual state that they are. That way we can just use the animator over again and change the animations for our other enemies. All right, for each of these, we're going to have to make a transition in as well as a transition out going to exit. From here, we're going to do something very similar to what we did in our player state machine, and that is create a bool for each of these states. So we'll start with is attacking, then make is idling, is running, and is walking. Now we can click on the transitions themselves, and for this first one, make sure it happens when is attacking is true. The next, and we'll have to click on entry to find it, is going to happen when is idling is true, then of course is walking, and finally is running. Now we'll exit each state when its respective bool is set to false, but we also want it to happen instantly. So we'll take off exit time and also set the transition duration to 0. We're going to want to do this for each of them, making sure that their bool is set to false when we leave, no exit time, and a 0 duration. All right, with our setup done, we're ready to get scripting. The first thing we want to do is make sure that our states can talk to our animator, and remember that all connection to the real world for our states happens through the enemy script. Up at the top in our components, along with the Unity components like rigid body, we'll make a public animator reference called anim, and again, this one's going to be a property. We'll then come down into awake, and as soon as the game begins, we're going to tell it that our animator is equal to getComponent animator. And before we go, I just noticed that I put animator, but the variable's name is actually anim, so let's fix that. Now that our enemy has that reference, we want to supply it to our states. Give it an animator reference as well. We'll call this one lowercase anim, since it's a normal variable. And then in the constructor, we'll make sure that it knows that anim is equal to the enemy's anim. Now we want to make sure that we can change our animation bools whenever we enter or exit a state. So first off, we're going to make a protected virtual string, and it's just going to be the anim bool's name, and it's going to start off as null. Now what we can do is come down into enter, and every time we enter a state, we're going to first of all check to see if it has a name for its anim bool. And if it does, then we're just going to tell our animator that it needs to set the bool of that name to be true. We can then copy and paste this entire line down into our exit method and just make sure that this time we're setting the anim bool to false. All right, the final step of this is to just create a protected override string called anim bool name. And here we'll actually tell it what the name is. So like I said before, for patrol state, we're going to use is walking. Now, as soon as we enter the state will make sure that the anim bool is set, and it will tell the animator to turn it on. All right, so now when we get in Unity, you'll notice that he's walking, and that's a sign this worked, as we set his default state to be idle. So when he enters the patrol state, he is in fact changing his bool. That said, he's floating a little. So let's go to Kobold and just make sure that his capsule collider is not below his feet. All right, with that fixed, we're ready to expand this a little. And the first thing we want to do is make it so that he can detect danger. If he sees something that is an enemy, we want him to chase that object or to stand sentinel if it's somewhere that he can't cross, like a chasm or on the other side of a wall. So if we need to detect danger, we need our senses. So let's head into enemy senses, where we can begin by setting up a serialized private transform. We'll call this one attack point, as it will do double duty as checking for both things it should chase and also things that it needs to attack. Down below then, we're going to set up another method similar to what we did for cliff and wall checks. However, this time it's not going to be a bool. It's actually going to return a transform. That way it won't just tell us if there is a target, it will actually send his positioning information to our states. We'll call this one getChaseTarget, and here we're going to return a collider 2D. We'll just name it hit for lack of a better name. And what we're going to do this time is use physics 2D again, but instead of a raycast, we're going to use an overlap circle. This will originate at our attack point position. Then we'll look in our config to find our enemy's chase range, and also in config to find the target layer. Don't worry that those don't exist yet, we will create them in a moment, but first let's finish this method. So we can come down here, and what we want to do next is first of all just check if we actually hit something. Now if we did not, then we'll just return a null value, meaning there's no enemy, so we send a transform that's empty. However, if our overlap circle actually does hit something in the target layer, then we want to return that object's transform. Now we still need to create our config chase range and target layer, but before we leave, let's just head down to our onDraw gizmos selected. Last time we waited until the end of the video to create these, and it would be nice if we had them actually while we're developing it, so let's do that now. This time we'll take our gizmos color and set it to red. Now the way we'll do this one, since we're not just drawing a line, is we're going to use gizmos.drawWireSphere. We'll pass in our attack point position and also our config's chase range. Again, we don't have that value yet, so let's finally go create those now. Alright, so over in our EnemyConfig, let's go down to the bottom and create a new header for chase values. We'll start with a public float for our chase range and initialize that to 5. And then let's make a public layer mask for our chase layer, and we'll just call this one target layer. Now we want to be able to test if this is actually working. So let's go to patrol state, and here we're just going to do a check at the start of our fixed update. So if our senses can find a target, first of all, let's just stop our enemy. So we'll get his rigid body's linear velocity to be equal to 0. We'll then just return so that it doesn't execute any further. And now I can just fix my typo, and at last we've got enough that we're ready to test. Now when we get in Unity, if you click on your kobold, you should be getting an error, and that's because our onDraw gizmos is trying to run but doesn't know where our attack point is. So let's just right click on the kobold to create an empty, and we'll call this one attack point. I'm then going to come down to my animation and go to the point where he actually swings. That way we can take our attack point and make sure that it actually is going to originate around the area we want to deal damage so it matches his animation. Alright, let's go back to our kobold and drag the attack point into our enemy senses. There should now be a red circle around our enemy that displays his chase range. If we go to our kobold's config now, we can tell him that our target layer is player, and then we can actually just change this chase range value, and then when we click on our kobold, we'll see that the circle is growing and shrinking when we change that value. Okay, so now when we get in the game, it'll look like it's not working as he's standing in place, but remember that's what we told him to do when the player comes within chase range, so it's actually setting his vector to 0. If we leave his chase range, he'll actually go back to regular patrolling. That's actually working exactly like it should be. Alright, we've done the hard work, let's create some states. First of all, let's make a folder for all of our enemy states. We can make sure to put patrol state as well as state inside of there. Then let's go ahead and create our next state. We'll call this one chase state. Alright, we'll do all the usual state stuff. We'll get rid of start and update, make sure that we're inheriting from state instead of mono behavior. Then we can come down and create our constructor. This will, as usual, have the same name as our state. It's going to take in a reference to the enemy, and then it will pass that reference along to the base state. We'll set up our animation bool the same way we did in patrol state, using a protected override string, and this time we want to call isRunning. For now, we just want a very bare bones chase state so that we can test that we're actually able to get to this state. So let's just, in our fixed update, create a debug log that says I am chasing something and sets our velocity to 0. That's it for now. Then we can head back to patrol and let's look at how we're actually going to transition between these different states. So first, when we detect a target, we no longer want to stop here. We're doing that in our other state. Instead, we just want to transition into chasing. So we'll tell our state machine to change state to a new chase state and pass along that enemy reference. Now, since this is our first state transition, we've got a little bit of hooking up to do, but let's use our console to actually help us with this process. You'll notice here that there is no definition for state machine in Enemy, so that's the first place we should start. Now when we get to Enemy, it will feel like our console was lying to us as there is a reference to state machine, but you'll notice this one is the capital S property and we're referring to the lowercase. That's because we don't actually want to talk to Enemy in order to get this reference every time. We want to cache it in our base state. So let's create a protected state machine reference called lowercase state machine. Then in our constructor, we'll make sure that this state machine is equal to that capital S property that we have in Enemy. Now when patrol state tries to talk to our state machine, it will actually be able to find it. Now it's great that we can find our state machine, but we're still getting an error, and this one's just telling us that state machine doesn't know how to change states yet. So we're gonna have to set that up. Now up until now, the only thing our state machine needed to do was to track the current state we were in, and also to initialize, which at this time is setting our patrol state as the starting state. Now we're going to use it as a way to change between states, so we'll make a public void change state method that will just take in a state which is the new state we want to go to. Whenever this is called, we want to tell our current state that it should run its exit logic. We'll then set our new current state to be that state we just passed in. And finally, we'll tell the current state, which is now the one we've moved into, that it needs to run its enter logic. Now for testing, I'm just going to move the player out of the way, and now in scene view, we can see that he's patrolling normally. However, when I run over and get close, he stops suddenly, which now that stop is only being called in our chase state, and we can also see in our console that he is chasing. So we are successfully transitioning between states. Now let's make our chase state actually do some chasing. Okay, so we want our chase state to be a state in which the enemy is always moving towards its target, and later will transition into an attack. So we need to actually keep track of that target, so let's use a transform reference for this. Then in fixed update, the very first thing we're going to do is set that target. So here we'll just call census and have it get the target. Now if there's no target, that either means the player's moved out of range or is dead or something like that, in which case we need to change states back to the patrol state. We'll then add a return statement so we don't execute any further. Now if we make it past that return statement, that means we have a target. So next let's ask our senses if we are hitting a wall or if we are at a cliff. If that's the case, that means we've got a target in sight, but we don't want to chase him blindly off a cliff, so we need to tell our velocity that it should go to vector 20, and then return, as we're just going to stand guard here as long as the player remains in range. Finally, we can come down below, get rid of our debug log, and if we make it all the way to the bottom, that means we have a target and there's no obstruction, so we need to chase him. So we'll set our linear velocity to just be equal to our config's chase speed on the X and our rigid body's linear velocity Y for the Y, so that we continue to have gravity. Now we do need to actually set a value for that chase speed, so let's go to our EnemyConfig, and just at the top of our chase section, let's make a float for chase speed and just initialize it to something like 7. Now back in Unity, we're going to have a disappointing test here, as the patrol's working just fine, and when we run and get inside of range, he turns to us, but you'll notice he continues to move to the right. And that's just because right now he's blindly using chase speed to set his velocity, and that's always a positive number. So what we need to do is actually figure out what direction he should be facing, and then multiply the chase speed by that direction. Now if we take a look in our enemy script, we can see that we already have a face direction as well as a flip. So we can actually use these, we just need to make sure that we're orienting our enemy towards his target. So let's create a public void face target method, and this is just going to take the transform in of whatever the target is. So first we just need to find out where the enemy is in relation to his target. So make a float called offset, and this is just going to take the target's position on the X and subtract the enemy's position from it. That'll get us the difference of their positions. Now we can use that to calculate what direction they are. So if the offset is greater than 0, and here we'll use a ternary operator with the question mark, and if it is greater than 0, we'll set it to 1. If it's not greater than 0, that means that it's on the left and we should set it to -1. Now we can figure out if we actually need to flip. So we'll just ask if the direction we just calculated does not equal the direction we're facing. If that is the case, we have a problem and we need to flip. That's it. Let's head back to our chase state now. Here, let's go down to the point where we know we have a target for sure, and if we do, then we just want to tell our enemy that it should face that target. Next, there's 2 jobs we need to do when exiting this state, so let's create our override exit method. And first, we want to make sure that we don't carry our velocity from chasing into whatever our next state is. So we'll set our linear velocity to 0. Also, we want to call base exit here. All right. Final thing we have to do is just fix that directional issue. Right now we will be facing our target as we did that logic, but we will still always be moving to the right. So let's just make sure we multiply our X value for our velocity by the enemy's facing direction. All right, moment of truth. If we come to the edge, it's working. When he gets to the patrol here at the end, he notices that we're there, so he stops. However, if we're close, he does chase us wherever we go. Now we are getting a weird rapid flip thing when he's directly on top of us, which we'll fix in a moment, but I'm quite happy with how this is coming along. Okay, so I promised earlier that in this video we'd, in roughly the same time as our last video, get a lot more done. And well, I guess we've kind of done that already as we've added animations, but now is where we really start to see the value getting added. In just a short time, we're gonna add a whole extra state here. So let's head into our enemy states and create a new mono behavior called idle state. Now, setting up a new state can be a bit of a pain, so let's not do it. Let's go over to our chase state, and actually I'm just going to copy all of it and paste it right in here. We'll of course need to change the name, which means our constructor will also need to get its name changed. Next, we want to change the anim bool, so in this case we're going to use isIdle. Next, let's define what happens when we enter the idle state. So we'll create our enter method and make sure that we set our linear velocity to 0, and I'm just going to copy that from below to make it easier. Now, we don't want to purely override enter, as our base state is running some logic there, which is what changes our animation. Now, keep in mind that this idle state is actually sort of a guard state. So let's continue to check if the player or other target is still around. If it isn't, then we'll go back to patrolling. Next, we want to make sure that we are constantly still facing that target, and while in idle we're unlikely to suddenly encounter a wall or a cliff, we'll leave those in there just as we don't want a micro movement to send us off a cliff or something like that. Finally, at the bottom here, we don't want to move if we make it through all of that. If that's the case, then we want to go back to chasing again. Finally, we can just get rid of our exit method altogether, as we don't have any special logic here other than letting our base state run its animation change, which it will do regardless. Okay, so we just wrote an entire state there. That said, we do need to make sure that we actually enter that state from other states. So let's go into chase state. And here, if we hit a wall or a cliff while there is still a target, rather than stopping, we want to go to that idle state. All right, now we're almost done, but remember that strange flip-flop thing we happened where the enemy got on top of the player and flipped rapidly back and forth? We want to stop that. Now, the reason that's happening is because he gets directly on top of the player, and then he calls his flip method. And because he's not absolutely perfectly symmetrical, when he flips, he's now just a tiny bit to one side, so he moves, and it just repeats. So we want to add a slight threshold to keep that from happening. So let's move our patrol speed down into patrol, which is where it should be. We'll make a general header and create a float for that turn threshold. Now we can head into our chase state. Now here, let's come into fixed update just below where we face towards our target, and let's see how close we are to our target. So we'll do a float for distance, and here we're just going to find the absolute value of our target's position on the X minus ours. So we get the difference between those positions, make sure it's positive, and now we've got our distance. Then, if the distance is less than or equal to our config's turn threshold, then that means we're close enough. We don't have to keep moving. We can just change state to, well, we'll do idle state for now. Later on, we'll use an attack state here. We can then return so that we don't fire any more logic. Now I'm just going to add a couple of quick notes to highlight this, as this is getting complex. First, we're going to check for a target. That includes facing towards it. If we make it past that, it means that we do have a target. So next, let's check to see if we've gotten close enough that we can stop chasing. Third, we want to always make sure that there is no obstacle in the way. And finally, if we make it through all of that, then we need to actually do the chasing. So let's move towards our target. Now let's copy that proximity check we just made and head over to our idle state. Here, again, right after we check to make sure we're facing the target, I'm going to paste it in there. Now, obviously we don't need to go to idle state once the player gets close. However, we are going to want to continually set our velocity to 0 when the player is close. Now let's just do a quick review. First of all, when we get into idle, we're going to always check for a target and make sure that we're facing it. Second, we want to check how close we are, constantly setting our velocity to 0 if we are within range. Third, we want to make sure that there's no obstructions or obstacles in the way, which is unlikely in an idle state, but it could still happen. Finally, if we make it through all of that, that means we've got a target, there's nothing in our way, but the target is not close enough to attack, then we want to go back to chasing. And with all that done, we can do a proper test. You'll notice he's patrolling over here to the left, and when he sees me, he runs at me. He stops when he gets to a cliff, and if I move out of range, he goes back to patrolling again. You can see that he does in fact stand sentinel on the edge in an idle, though you'll notice that he's not actually playing his idle animation. That's a problem. We did get rid of that constant flipping, though you'll notice that he gets really close, and that's a little uncomfortable for me. So let's do a couple little tweaks here. First, let's take a look at the animator, and you can see that I have a bool called isIdling. This is my problem. If I go into our idle state, you'll notice that I told it to set the bool for isIdle to true. That should be isIdling. All right, the other thing we just want to do is quickly make sure that we click on our enemy's config, and let's give him a larger threshold so that he's not getting quite so close. That's better already, though I might increase it even further. I'll let you decide what's right for you. But otherwise, this is looking pretty great. That said, we don't want enemies that stop when they get to the player. We want some attacking. So in our next video, we're going to head towards some combat. Hope to see you there. Until that time, this is Matt with Night Run Studio. Cheers.